Right, absorption. Oh yeah, done this part already. Absorption continua, or just the range or the continual nature of absorption, which stands for, which means continua, the continuation of absorption. From 0 to 0.3, instead of scattering, now we're looking at absorption. So UV radiation is less than 0.1 micrometer. Do you remember that? Visible light is 0.4. Anything below is UV already. So anything much below than that, about 0.1, is definitely UV radiation or ultraviolet radiation. Now this radiation can photoionize or can oxidize or can disassociate atoms by stripping the electrons from the atoms because it has high energy. So, but radiation less than 0.24, here is less than 0.1. This is very photoionizing radiation, very strong radiation, because it can literally take up the electrons from the atoms because of the amount of energy it has. So more than 0.1 but less than 0.24 micrometer, the radiation, still ultraviolet, can break oxygen atoms into oxygen molecules into oxygen atoms. So oxygen molecules, you get hit by the radiation, it breaks into oxygen atoms, 2 oxygen atoms. Anything less than 0.24. So anything more than 0.24 but less than 0.31 can break ozone, O3 atoms, ozone molecules into oxygen atoms. So this process, removing electrons from atoms of any gases in the atmosphere, breaking oxygen into O atoms, breaking ozone into O atoms, and so on, this process absorbs all of the UV from the sun. So that's why we don't receive that much ultraviolet radiation from the sun, because of this process. It filters out all this radiation of this very strong radiation in this range before it reaches the surface of the Earth. So the radiation that reaches the Earth's surface is more than 0.31, or the visible light as well. And also the light that is essential for photosynthesis. Remember? So here we see that's the continua. You see less than 0.1, it breaks up this molecule, these molecules, nitrogen gas, nitrogen, and also oxygen. It strips off the electrons from these atoms or molecules. Then it reaches this point, and then from this wavelength range until this wavelength range, it breaks up oxygen into OO atoms. And then from this point to this point, it breaks up the ozone atoms. By the time it reaches, by the time it goes through a certain depth of the atmosphere, all of the radiation that's less than 0.3 micrometer will be gone, will be extinct. So this is the continua of absorption. So radiation that is more than 0.31 or micrometer, or the visible or infrared cannot photoionize, cannot break molecules, or photodissociate, means breaking it up, the gas molecules. But it can still absorb energy. Even though it doesn't break it up, it still absorbs. That means the oxygen atom, the oxygen molecule absorbs the energy into the molecule. So gases can absorb radiation of more than 0.31 micrometer at specific wavelengths. Different gases only absorbs energy of a certain wavelength only. So oxygen and nitrogen gas can only absorb radiation at a few wavelengths. So it still absorbs energy, but only this specific wavelength. But the greenhouse gases such as water vapor, carbon dioxide, ozone, methane, nitrous oxide, carbon monoxide, CFCs, they can absorb more radiation because it can absorb more wavelengths, more radiation of different wavelengths. You can imagine, well, although this is not the accurate plot, but let's say a certain wavelength, oxygen maybe can absorb this wavelength only, but then like say CO2, it can absorb a lot more wavelength. So it means that it retains more energy than oxygen gas. That's why they call it the greenhouse gas. And they can absorb more wavelength lines in the infrared region of the spectrum. That means more than 0.7 micrometer.